Can we have a look at this calculation, please? How often was this compounding? Yearly? And how many years was it for? 3. So how many calculations did we need to do? 3 lines of calculation, okay? I'm going to teach you a formula for compound interest, but you'd be like, what? I can just do this. Yeah, you could do that. But what if the question said for 3 years, compounding monthly? How many months would that be? 36. Do you really want to do this 36 times and stuff up a number and then have the wrong answer at the end? Okay? So the point of the formula is so that you can do any situation. The compound interest formula looks like this. So get that down, please. Classes from last year, you'd be familiar with that, but you pretty much forgot about it when you did TVM Sol. All right? I reckon I'm getting the sense that they just hammered this the whole time. So the compound interest formula looks like this. FV equals PV times by 1. It's always 1. Plus I divided by K in the brackets. Close the brackets here. And then that's a power. It's to the power of K times by N. Get that formula down, and then we'll go through what the little codes mean. Sorry, which one? Oh, I over K. How do I guess because I made the tail. I over K to the power of K times N. What does FV stands for? It's the final value of the investment. It's what it grows up to. PV is the principal, what you started at. I is the interest rate as a decimal, so you just divide the percent by 100. What does K stand for? It's the number of compound periods in a year. So if it was compounding yearly, K is going to be 1. If it was compounding monthly, what would K be? 12. So you need to do some thinking here. If it was compounding quarterly, how many quarters are there in a whole thing? 4. If it said half yearly, how many half years are there in a year? 2. Okay, so you're going to experience all of that. Heck, I'm going to be doing this literal formula with my year 12s in late term 2. Okay? What is N? N is the number of years. And please note, this formula tells you the final value that the investment grows to. To find the interest you earned, interest is equal to FV minus PV. I'm going to put a cross there. Can you get that whole block? Did you have something to add? Or?
No, you wanted to see what that was in the top right.
Top right?
K times N.
K times by N, yeah. If you can't read it, there's the blanks on day map. Don't make them waste, so that's an extra step I'm doing for your class. Couple of minutes and then I want to demo this formula. You need to use BEDMAS if you're using a calculator. And let's have a go. I'll try to fit it in the space off to the side. Find the interest earned on a $100 investment of 5% compounding yearly for 3 years. That was the last thing that we did on the previous lesson, but we're going to use the formula to do it. Can you stop until after, boys? Can you stop until after? I know you know this, but you had my class. Not everyone had me, okay? FV. I can't find the interest yet because this formula doesn't tell you the interest. It tells you what it grows up to. So I need to find the FV and then use this formula to find the interest. FV equals PV. What did I invest? I invested $100 times by bracket 1 plus, what's 5% as a decimal?
0.05.
0.05 over k. K is the number of compound periods per year. If it's compounding yearly, how many times does a year happen in 1 year? Once. That's my k. And then to the power of 1 again times by n is the number of years. How many years was the arrangement for? 3. I have a more advanced Apple calculator. So what you'll do, you need to do BEDMAS. You need to deal with the brackets first. So 0.05 divided by 1. I'm dealing with this, the fraction in the brackets first. Add 1 to it. So it's 1.05 to the power of, what's 1 times by 3? 3. So 1.05 to the power of 3. And then I times it by 100. So 115.76, which is the same answer as we got last time. 115.76, 115.76 to 2 decimal points. So the interest is what it grew up to, $115.76, minus what I put in the first place, which is 100. So it's going to be $15.76 interest. Using the formula, rather than doing it year by year, let's do a more realistic example, placing 8,800 in an account. So a lot of you might be earning money from a job, you might have got inheritance from grandparents or something. Put it in an interest saving account. So it's earning money for you. Too late to invest in crypto these days. You don't have enough money to buy real estate. Shares are risky. Unless you come to a lunchtime shoot and then we can talk about it. There's one kid that's ever earned money off the share market. Wasn't even my student. But he invested in Qantas in the middle of COVID. So he bought like thousands of shares of Qantas at like 2 cents each. And then when the plane started going again, they were $3.50 or something. So he took a gap year before he went to uni. He shook my hand on the last day of school. Like, thanks, bro. All right, let's do A. Find the contents of the account after 3 years. FV is going to be the contents. What did I put into the account? I placed 8,800 in there. Times by 1 plus. What's 4.8% going to be as a decimal? Not you guys, only you. There's other people in this room. 4.8, if I divide that by 100, what's it going to be as a decimal?
0.048?
Yes. 0.048 over compounding yearly, so k is going to be 1 to the power of k, which is 1, times by 3 years, 3. BEDMAS. 0.048 divided by 1 plus 1 to the power of 3 times it by 8,800. That tells me it's going to grow to $10,128. Oh, that's going to round to $129 to 2 decimal points. That's a bit better growth. That's not only $15. Why is that? Because you started off with a bigger amount in the first place. 4.8% might not seem like anything, but 4.8% of a big number is kind of a big number. And B, find the interest earned on the investment. Interest is what it grew to, 10,129.00 minus 8,800 equals $1,329. So if you were to do that, and that's kind of realistic because that interest rate isn't crazy different to what we have right now. If you put 8,800 in the bank at that rate for 3 years, you would be paid 1,329 for doing it. Okay? So please, what you're doing right now, ignore this example 3 because we're going to do that on Monday. You're working on 3C1 and 3C2. using the compound interest formula is the second.